Sup guys, welcome to today's show. So, today we are going to continue our Hyperbird project, which is my HTML language for C. Last time we created a lot of the basic structures and succeeded in creating a string data type that we can successfully chop off the first byte and return it. So pretty simple stuff thus far. I want to refactor a little thing though. This text token that I have, I want it to have the same structure as the other tokens. So let's do something like struct s text token. And we'll give it a tag with the type and an int 8 with the value, like so. And we will type def our struct s text token to text, like this, and remove this part. So now I want to create a show function which will print a token. So let's see, I think I'm going to, before that by the way, I figured out how we can remove this thing, this duplicate code. If we just remove this like so, and we go to Hyperbird and we remove the include of tokens, and let's put it inside of our C file instead. I think that was going to work. Let's see if it compiles still. No. Redefinition of struct s token. Maybe I didn't save this one. Okay, now it works. Good. We should be as dry as possible, right? Don't repeat yourself. Okay, so let's create a signature for this function. Two functions, actually. I want to have a void show token, and it will take a token. And I want to have a void show tokens pluralis, which will take tokens. And I wonder if I should create its own C file as well, but I don't think I'm going to do that. So let's do void show token, or wait a second. Maybe we should not return void. Maybe we should return a string instead. Yeah, I think I'm gonna do this. Because then we can simply print that string, and maybe we'll use that string for other stuff as well. So this will be int 8 show token, and it's gonna take a token. And what are we gonna do? Well, we're gonna have a ret, and then we will switch on the token dot type, right? Yes. And if we have a text, I think I just called it that. Let me copy this stuff. Let's take all of this. And we will put it right here inside of a comment for now. Or it will always be a comment until we remove it. And maybe clean it up just a little bit. We don't need all of this stuff. Alright. So if we have a type text, what are we going to do? We are going to set ret equal to what exactly? Maybe we should make this a pointer after all. It'll be easier if we just do let's create a TMP with a size of, I don't know, let's say 32. No, maybe we need it bigger. 256 is good. And let's zero out this thing. And I'm gonna keep the ret though. And let's assert that we have a token. We can perhaps do token dot type. So if that is 0, it's an error. Alright, so let's see. Now we can use s and printf. And we can put our TMP size 255, and if it's a text token, we'll just copy that text, and that'll be token dot text token dot value, like so. Maybe we can even do this. And maybe we can do a couple of copies. And what else do we have? We have a tag start. And in this case, we want to print it like this, right? And it's not a text token dot value, it is start value. we'll do the same by tag end, but this will be a slash as well. And finally we have this self-closed thing, and I want to print this like this. And maybe we'll have some default kind of thing, which will only be well, nothing. We can have the default and maybe even a break, but the string will be empty, right? Let's see if we can tab this out and still make it fit. Yeah, that's kind of cool. And then we will simply return the ret, right? So that is when we have a single token. What about tokens, pluralis? Let's take this thing. And put it inside of our comment. We can remove the other stuff. So this will be int a show tokens, and we will have a tokens structure. So now we need to go through this list of tokens and concatenate that to our string. Right. So let's see. We need to be careful here so we don't overflow the buffer. We can make it kind of big, let's say 2048. Let me just do a quick calculation. So if we have the maximum to 2048 and the maximum size, oh, not echo, expression, right? Okay, that's only 8 of those. But most of them are very, very small though. By the way, we can't really return this thing. We need to make this a static. We can't return stuff in this function stack. Well, we can make this kind of big actually. Let's add a 0. So in this case we will have 80 of those. I don't think we will go past that. And we need to have an int16, which makes sure we don't overflow. Let's create one for the total size and one n for each and every one of those. Let's also create the pointer p, and we also need to have a token pointer t, and we need to have a variable which makes sure we don't loop past the length. Let's make that I. Alright, let's see if we can get this to work. We'll have a for loop where we set I equal to the token's length. And let's loop as long as we have an I. And let's just do I++. We can also set our t equal to, maybe we should give this a name though. This is t's, plural. T should be equal to the t's. That's this thing, the list of tokens. And we will decrease I, but we will increase t. Okay, so let's see how we do this. We'll set p equal to show token, and we will give it the current token, which is t. And if we don't have a t, we break. And if we don't have p. And if we don't have any length of this p, we can continue. Otherwise, we will calculate the string length of p, and we will add that to our total. So total plus equals n. We also need to zero initialize this total. And if total is more or equal to size of buff, we break. Otherwise, we'll do a string copy. We need to have something pointing to the current point in the buff. So let's set cur equal to buff. And what are we going to string copy? Well, we're going to copy it to the current position inside of our buffer. And the thing we want to copy is p with the size n. Then we need to increase our current position by the same number of bytes. Let's see so I don't miss anything here. So when we have copied this result, we will increase t, go into the next token, we will decrease I. Yeah, I think it's okay. Let's also zero out the buff in the beginning. And we do need to make this a static buff. So we, at the end, can return our buff. I hope I made this right. How can we test this? We need to create a couple of tokens, right? So we can remove this comment. And let's grab this part again. Because we remember this text, tag start, tag end, self-closed. So let's go inside of our main, clean this up. We will create a comment where we paste this thing. Alright, so let's create a couple of tokens. Let's say token HTML. And I will cheat and do it this way. This should be equal to, the type is a start tag, tag start. And right, we have this union thing. We can probably just do content. No. Can we do dot content? Dot start. Maybe we should break this up on several lines. And let me just check how start token looks. Right, all of them looks the same. We have a type and a value. Okay. So let's do this again. We have token HTML is equal to a type which is a token start, a content, I wonder if we can do something like this. And inside of here we will have a start. These are several levels. I'm not sure if we can initialize it like this, but let's try. And here we set the type again to token start, and we set the contents to HTML. Let's start here actually with 1. And we'll do a print f. Let's put it inside of quote so we see a little better. And what are we going to print? Well, we're going to print show token HTML. And we'll return 0. Alright, I think we need to edit some stuff inside of where exactly. This is probably okay. But here, token, text token. We probably need to add contents as well, which break this up in 2 lines, unfortunately. And we'll do the same here, contents. And finally, we'll do the same here. Contents. And this does not fit at all. Okay, it's become quite a lot uglier than before, but maybe we shouldn't care too much about that. I want to make it work though. Okay, let's see if we can print this HTML token and if it compiles with this weird structure. So we'll make clean, we jump down a little bit, clear the screen and run make. Oh. Wow. So let's see. Expected parentheses before the dot token. Yeah, okay. 38. It's here. Yeah, we kind of need to name it something. Let's call it T. I thought it looked weird, but I didn't really know why. I wonder if this makes it possible to get everything on a single line. Maybe it does. This works. And this. And this. Well, this will not work. At least I don't think so. No. Annoying. Well. Okay, let's see if this fixes things up. Well, still a couple left. case pointer targets in passing argument 1, right? We need to convert as well. This should be a char. And we're back at this line break. Maybe we can cheat a little bit. And we need to do the same here. Need to cheat a little bit more. And same here. Same here. All right. Okay, that's better. Error union anonymous has no member named self closed. So it's text token start and then self. Huh. Look, no. Okay. All right. Type equals token start undeclared. Token start, it should be tag start. The words are too similar. Tag, token. I will probably make that mistake many times. Tag start, blah blah blah, has no member named contents. Tag start. Right, it should be data, I think. Value. And we can't initialize it like that. Can we do this? Nope. Alright, that's a minor problem though. No, wait a second. This is a flexible thing. That's right. So this inner part we need to malloc. So this start thing, what is it? It's a tag start. So we need to have a tag start pointer which we want to malloc like this, size of tag start struct s tag start. We assert that we have a P. We zero out that P. Size of struct s tag start. And then we need to string copy into this value HTML, and this needs to be int 8 4. Think this is gonna work, and now we can probably just set start equal to P. I guess, because we have the contents and we have the start. Let's try that. Perhaps we need to make it a pointer. Incompatible tags when initializing enum etag using type tag start. Start is a tag start. Inside the contents we set start equal to P. It's a weird error message, but perhaps it is because it's not a pointer. So let's make these pointers. Which means we probably need to edit our print token function a little bit. Show token, I mean. Because now this needs to be an arrow. Let's cheat a little bit more. And now I think it'll compile. It did. Let's see if it will print an HTML. If everything works, it should print this, right? Hyperbird. Okay, so far so good. Now we just need to create a couple of those. Which is no easy matter. All this code just to initialize one. That tells me what exactly? That we need to have a constructor function. So let's turn this into a constructor function, which will return a token, make token, and what is the input? Well, we need a token type, don't we? Token type. and we need a value. So token type, and we need to have an int 8 value, like this. Right, so the only thing we need to change is this right here will be the value, and this right here will be the size, which we need to define int 16 size. And size, let's do this after. And size will be equal to the string length of value. At the end, we will simply return p. Let's put this inside of here. Constructor functions, constructors, token star, make token, token type, int 8 star. Like so. Maybe we should, no, we can keep this. And now our main will be easier to create. We can simply do something like token, and we make a couple of those, T1, T2, T3, T4, and T1 will be equal to make token. This will be an tag start and HTML. Our second can be, let's say, body. Then we'll have, we need to change this as well, tag start, and this will be a text. Hello world. Let's insert a BR, and that is a tag. It's a self-closed. And then we'll have a tag end for the body and a tag end for the HTML. So let's create two more of these variables. We'll have a T5 and a T6. Alright, so how do we put all of these inside of this other thing, the tokens structure? Well, first we need to allocate this. So let's define an int 16 size. Let's define a tokens t's. Maybe we can wait with the t's. We do, however, need a t. Yeah, let's do that. So t will be token, and we're gonna malloc the size. And what is the size? It's the size of one token times 6, because we have 6 tokens. Let's assert that we have a t. Let's zero out the t. And let's put some content into it. And this should just be an array, basically. So I guess we can just do t0 equals t1. Like this. And now we can create our t's, which will be tokens. And it'll have a length of 6. And it'll have a, what did we call it? T's. It will have a t's of t in this case. And let's do printf. And this time we're going to do show tokens, plural, and we give it the t's. All right, this will be interesting. And let's clean up a little bit. Let's see. What do we need to clean up? The make token, what does it return? It returns this. And let's see. Yeah, we need to have a destroy function. 2 actually. We need to have something which destroys a token and something that destroys tokens plural. Maybe we don't need the second one yet. So how do we destroy a token? Destroy token. And we have a token star t. Yeah, we just need to do free on it. So let's create an alias instead. Which will be a macro. Let's call this define destroy token, and we have a t. And this will just do free of t. For now, anyway. So we need to destroy token T1. 2, 3, 4, 5, 6. What else do we malloc? Well, we do malloc the array inside of the tokens structure. So let's just do free teas dot teas for now. All right, let's see if we got this right. Oh, what's that? Conflicting types for free. Have void star. Oh, maybe I didn't delete the. Did you know that I made a book about computer networking? You will learn how the internet works and how everything works under the hood. It's a complete beginner's course, but it has some advanced elements as well. And you will learn network design and network security and all different kinds of stuff. For more info, check out books.drbirch.com. That is books.drbirch.com. Thank you for your support. All right, welcome back, you guys. Let's continue with our troubleshooting. Came to think about something though. This isn't really nice. So I'm going to code a function, or rather a macro, which will destroy a list of tokens. So let's see. Let's go into this. And we already have a destroy token macro. This will be a destroy tokens macro. And it will take a tease. And what are we going to do? Well, we're going to do something. Let's start by defining a variable. Let's do int 16 n, and then we'll do a for loop where we set our n equal to the t's length, and we're going to loop as long as we have an n, and we'll do n minus minus minus. And let me don't forget those backslashes. All right, so what are we going to do inside of this loop? We're going to call destroy token, and we're going to give the t's dot t's and the n as an index. And when we're done with that, we will also free the entire thing. So that'll be tease dot tease. Let's put this inside of parentheses. It's a good standard to always put the argument to a macro inside of parentheses, because you might want to send like an expression as an argument, and that won't work in all cases unless you do like this. And let's also don't forget the semicolon. And when this is done, we need to end the loop, and we'll end it by saying while false. So we will not loop. We will only use this as kind of a lexical scope. Kind of thing. All right. So now that we have this thing, we don't need to do all of this ugly code. All we need to do is call destroy tokens and give the tease, like so. All right, so let's see what else was problematic. We had a lot of errors relating to returning tag start star from a function with incompatible return type token star. 191. It's this thing. So we return a P, which is a tag start. Why did we make this a tag start? That's weird. Make token. Let's see. A token is this thing. So it can be tag start, but also these other stuff. I guess we should return HTML in this case, but this will only create a tag start token. How can we make this more general? I guess we can't. We have to make different functions, I suppose, because almost everything is different. So let's rename this to make tag start. It will still return a token though. And then we don't really need this token type kind of thing. And where did we use that type? Did we even use it? No. Alright, it will not be very good looking since we have to copy paste some code. But let's just make it work for now, and then we can refactor and make this look better. So we have a tag start. Let's make a tag end. So we'll need to change this P to tag end, and same here. What else? This needs to change. Tag end. And start needs to be end. And this needs to be tag end. I think that's it. So let's make a self-closed as well then. And we need to change this, self-closed. And we need one for the text token as well then. Let me just double check that I picked the right variable names for these. So we have text and text token. Text. And where is the here text token? So this should be text token as well. And now we can create our make token. And it will have the same signature as before. So token make token and token type and what's the other one? Indate value. So we will switch on the type, and if we have a text, we will return make text value. If we have a tag start, we'll return make tag start. And then we have tag end. And finally, if we have self closed, we'll return make self closed value. And default, I don't know, we error out. Alright, like so. Let's also create a couple of constructors. The token make something, and we give an indate star. And we'll have make text and make tag start, make self closed, and finally make tag end. Alright. And we still call this make token. Do we pass the right arguments? Seems like. Alright, let's see what it says. Initializer element is not constant. Okay, so the initializer needs to be constant. That's very annoying. So we need to do HTML dot contents dot start equals p, and remove this middle part. Right. Same here. And HTML content end is p. And finally the same with the text. HTML contents text token is P. Okay, let's see if that works better. Incompatible types when returning type token instead of token star. We should be able to fix that with a cast, I think. It's a little bit annoying when you have 4 functions and you need to change stuff in all of them. Well. Let's see if this works better. Cannot convert to a pointer type. Oh. Well, I suppose we just have to create a pointer then. Token ret. And ret is equal to HTML. We probably need to make this, no. And we'll return ret. And finally the same with our text. Shouldn't have the name HTML either, because this can be any of the different types. Never mind. Incompatible types when assigning type token star from type token. Isn't the whole point of a pointer that you should be able to point it towards a variable of the same type? Okay, let's take the address instead then. Is it just me, or has GCC become dumber of late? I'm pretty sure it could deal with this stuff on its own before. Alright, that's better. Assignment to tag start star from incompatible type self closed. 225. Forgot to change the type. self closed. Did I with the other ones? This is tag end, tag start. What about text? Yeah, that too. Little by little, it's starting to take form. What now? Didn't I save? 225? All right. Conflicting types from main. Yeah, that's easy enough to fix. Pointer targets in passing. Argument 2 of make token differ in signedness. Okay. Let's see. Let's start with main. This should just be a void for now. And then we have a little bit of trouble with these. So let's convert them. We need to have them as int 8 and not char. And now I think most of the errors will disappear. Yes. Incompatible types when assign its type token. From type token star. Okay, same thing. From type token double star. Maybe we need to go the other direction then. All right, that's more like it. I is undeclared. This is inside of our macro. Typo. Anything else? Expected blah 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 before 4. It's the same thing. Maybe it compiles now. Almost. Incompatible type for argument 1 of free. What do we have? We have tease dot tease and then n. Definition of macro in expansion. Tease dot tease and then one of them. Do we need to do reference? Invalid type of unary star, have token, struct as token. What about this? Alright, it's compiled. But will it work? Hyperbird. Corrupted top size. Corrupted top size. I have never seen that before. And malloc is failing. Weird. So which is the first malloc we do? It's probably instead of make token. So we go to the make token, and this is the tag start. So we go here, make tag start, value. And p is equal to tag start malloc size of struct tag start. Let me just put an exit here to see if this is actually the one that causes this. Yeah, it is. No, it's not, I mean. So which one is it? How many mallocs do we have? Let's copy, we have already tried, I think. Make string, same there. Make tag start. Size of token times 6. Let's see. Size of token. And what should this tease contain? Well, it's an array of tokens. But shouldn't it be an array of pointers to tokens? I think that makes more sense. So let's make this token star instead. And let's change this to this. And we probably need to change a few dots to arrows as well. Let's search for T's. Show tokens. T equals T's. T's. Let's see what it says when I try to compile it now. Maybe this is not the right way after all. I don't want to change too much about these tokens because we already was able to print. No, maybe we haven't been. Let's see if it's this malloc that fails. Let's see what it says. No, it's not that one. Let's do something like this then. One. Let's also flush the buffer. Two, three, 4, 5, 6, and 7. Let's see how many numbers we get. Interesting. We get the 4, and then it fails. Which means that if we put an exit 0 here, we should still crash, right? Yes. But if we put this here, we shouldn't crash. Okay. At least we got some intel. But now I forgot which one it was. We got the 4 and then we crashed. So it's a self-closed. What's different about the self-closed? I think I made all of them pretty much the same, didn't I? Tag type int date value. What happens if I remove this assert? Okay, so it's not the assert that prints the error. It's actually malloc itself. This is really weird. Is it something to do with the size? Okay, it's not that one. So it's not the self-closed. Is it this, maybe? Okay, so it's a text token. So P is equal to text malloc size of struct as text token. And if we comment out this thing, then the assertion fails. Okay, so let's do the same here then. Print the size. Because that is the only argument to malloc. What else can it be, right? Size of struct as text token. 4 bytes. The tag is probably 4 bytes. What about the value? What do we do with the value? We allocate one of those. I forgot to take that into account. But how does malloc know of that? Weird stuff. But let's first calculate the size. Let's create an M size for malloc size. And we'll set M size equal to size of struct s text token plus the other size. And we'll give the M size to malloc and to our 0. Okay, so this is how the code was supposed to look like. But why does only this trigger whatever this is? Well, so we'll have a, oh, I forgot, I need both. And so size och M size. Do this. M size is size of struct as self closed plus size. Alright, and we'll do the same up here. Size, M size. Move this up, set M size equal to size of struct s tag end plus size. This is M size. This is M size. And finally, let's do the same for this tag start thing. M size. Alright, let's see what happens this time. Huh, now it works. Almost. Double free or corruption. But it prints exactly what I was hoping it to print. Great. What about this double free? because we allocate for these, assert, we zero them, put into this, and here, and then we just do destroy tokens. Do we loop too much? Let's see. N is the length. And as long as we have an N, we go and we decrease. And we destroy that token. Maybe we should just do this in this case. So now we're back at this. T's is equal to T. What if we do, let's see, this and T's, and we want to have the address of this plus this. Will that make a difference, perhaps? Incompatible type for argument 1 of free. Cannot convert to pointer type. Okay, now it compiled at least. But we still get that thing. But perhaps it's this line. No, it's not. What if we were to send the reference instead? Now it compiles. '83, 11. Maybe we should go the other direction. So we set n equal to 0, and as long as n is less than t's length, we increase it. Will that work? Who said garbage collection is easy? Maybe we should make it in 2 steps instead. So if we do something like void p is equal to and then we give this pointer to destroy token. Something like that. Let's compile at least, but invalid pointer. Well, I don't want to put in any more time in this for now. I will figure it out later. For now, we will just leak the memory. Let's make a... No, let's do this. So now we know that this needs to change later on. Useless type name in empty declaration. Well, that's kind of the point. Okay, so it works. We just need to figure out the garbage collector, and that we can do later. All right, so now all the prerequisites are basically done. And the next thing we're going to do is take care of our parser. So thanks for watching, and thanks for today.